All right, simplifying radicals. Like I said, this is the last lesson of the unit before we move on Wednesday. Radical expressions whenever you have a number under the square root symbol. Now, all these parts, or the square root symbol actually has a special name. Okay? The name of this symbol is called a radical sign. The only reason that we call it a square root symbol is because whenever there is no number here in this spot, it is understood to be the number 2, which stands for square root. Now, there can be other numbers there. There can be a 3, which is called the cube root. There can be others, like 4, 5, whatever. Okay? 4th root, 5th root. But all of those numbers, the numbers in that spot are called the root index. We only work with square root, so you really don't have to know all this vocabulary. But this is an expression with the radical sign. Radical sign. Okay? When simplifying a square root, you want to list the principal or positive square root. Because we've been working with the plus minus symbol, so we're only going to work with the plus symbol today. The number under the square root symbol is called the radicand. Or the number under the radical sign is called the radicand. Okay? Now, there's certain things that you can do with the number under the radical sign. One of them being the product of property of square roots. That tells us that when you have a number that, say, for example, you have the square root of 14. What two numbers can you multiply to get 14? 7 and 2. You can split up that 7 and 2 into their own radical symbols. Okay? So the multiple of a and b, that being my 14, can be split up to the square root of a and the square root of b. You can split those up. That's called the product property of square roots. Using that fact and knowing that the square root of 100 is 10, we can rewrite 100 as a product of perfect square factors to demonstrate the property. So to get 100, I know I can multiply 25 times 4. I split them up into their own square root symbols, into their own radicals. The square root of 25 is, and the square root of 4 is. Then we know that 5 times 2 is 10. Just a longer way of getting to the 10. Now, a square root radical expression is simplified when the radicand, or the number inside of the radical sign, has no perfect square factors other than 1. We simplify it when it doesn't have a perfect square. Some numbers don't simplify, because if, for example, the square root of 15, the only multiples of 15 are 1 and 15. It's a prime, so it is in its simplest form. There are no perfect squares within the 15. But if you look at the square root of 12, one of the multiples of 12 is 4. 4 is a perfect square, so that is one that can be simplified. Now, how do we do that? We can use the product property of square roots and our knowledge of perfect square factors to simplify radical expressions. Looks intimidating. It really isn't that bad. Okay? So the first thing you want to do is you want to find the largest, not any, the largest perfect square factor. You rewrite the radicand as a product using the perfect square factor and the product property. Always list the perfect square in the front. Take the square root of any perfect square. So, example, simplify the square root of 24. We know that multiples of 24 is what times 6? 4 times 6. If we split that apart, we can have the square root of 4 times the square root of 6. We know that the square root of 4 is 2. So in its simplest form, the square root of 24 is 2 square roots of 6. You cannot simplify the square root of 6 any further. Okay? So let's flip it over if you don't have any questions so far. Number 1. The square root of 1 is 1. 1 times 1 is 1. Square root of 4 is 2. 2 times 2 is 4. Square root of 144? 12. 12 times 12 is 144. These are perfect squares. These will give you whole numbers when you type them into your calculator if you don't know your perfect squares. Okay? But one like the square root of 8, if I go look at my list, 1, 4, 9, 16, 25, the square root of 8 doesn't belong in this list. It's not a perfect square, so we have to simplify it. In order to simplify it, I must first write down the multiples of 8, starting with the number 1. 1 times 8, 2 times 4. Out of these 4 numbers, 2 of them are perfect squares. Which ones? 2 is not a perfect square. 1 and 4. Now, out of 1 and 4, I always keep the largest one. So I'm going to keep this pair of numbers. When I write it or when I split it back up, I need to make sure to write the 4 in front. So I split it into the square root of 4 times the square root of 2. I can take the square root of 4 and it gives me 2. But since square root of 2 gives me a decimal, I bring it down. And it gives me 2 square roots of 2. That is my square root of 8 in its simplest form. Let's look at one like number 5. 60 is a number that is not on my list. The number that is on my list, 36, 49, 64, but 60 is not there. So I need to simplify it. Okay? So I write down the multiples of 60. If I don't know the multiples of 60, how do I find them in the calculator? We've done that so many times. How do you find the multiples of 60 in the calculator? How do you find the factors of 60 in the calculator? What do you put into y equals? What should you have done on the test on Friday? Do we seriously not know? Crickets? 60 divided by x. 60 divided by x, then go to your table, second graph. Always start with the number 1. Always use the whole number. So 1 times 60. Oops. 60 is an even number, so I know 2 times something. 2 times what? Then what? 3 times 20. Then 4 times 15. What else? Okay. You got a bunch of multiples, but only 2 of them make the cut. Only 2 of them are perfect squares. Which ones?
1 and 4.
1 and 4. So which one are we going to use? 4. 4 is a very popular perfect square that we're going to use today, but it will not always be 4. So don't get excited, okay? Don't always look for the 4. Look for all of them. Pick the largest one. The square root of 4 is, bring down square root of 15. 15 is a prime. The only thing you can, oh no, it's not. You can do 3 and 5, but that you can't take square root of 3 and 5. So. All right, number 6, ready? Multiples of 27, go. 1 times, what else? Is that it? Okay, so what are my perfect squares? 1 and 9. With the largest one being 9. When you write it, put the 9 in the front. What is the square root of 9? 3. Bring down the square root of 3, and you get 3 root 3. Questions? Number 7. Multiples of 18. What are they? 1 times 18. 2 times 9. 3 times 6. What are my perfect squares? 1 and 9. So my largest one being 9. So we break it into the square root of 9 times square root of 2. The square root of 9 is? We get 3 square roots of 2. Questions? All right. Number 8. Multiples of 20. 1 times 20. 2 times. Yep. So my perfect squares are 1 and 4. Obviously, we use the 4. So when we take the square root of 4, we get 2 square roots of 5. One more. Unless y'all need more examples. So, multiples of 32. 1 times 32.
2 times 16.
Uh-huh.
4 times 8.
And then 8 times 4, so you know you can stop. What are my perfect squares?
9.
And anybody that's rushing will miss the 16. Don't rush, because there can always be a larger one. And if you don't list all of them, then you can miss it. Square root of 16, square root of 2. The square root of 16 is,
4.
so we get 4 square roots of 2. Does anybody need to see more examples of this? Or you think you got it? All right.